Hello and welcome back. Conversations in Artificial Intelligence. Once more, Paolo, your host. Thank you so much. If you're returning to the channel, it is an honor and privilege to have you here. So today, we're gonna go into science and engineering, and we're gonna cover a number of interesting topics with a very special guest. He is a former physicist, scientist, who then turned into a combination of data scientist and engineer. He's been around Silicon Valley for quite a bit of time, jumped from one project to another. So he's one of those people that I call Silicon Valley character. So this person goes by the name of Mike Mian, and he's currently the CTO of a stealth mode healthcare machine learning artificial intelligence startup. Hi, Mike. How are you today?
Hey, I'm very good. Thank you.
So, Mike, first of all, thank you for being here. And let me ask you this. If I was to go back to Liverpool at the time where you were studying there in England, and I had to kind of reintroduce you to your friends at that time, what should I tell them?
I don't know. I would say, they'd be, I guess, interested to know that I kind of ended up somehow using a little bit of my physics, the maths part anyway, in my work, as a sort of studying physics and theoretical physics, you write a lot of code. So, I ended up using those software engineering skills as well as the math skills. Initially I left university and after doing my PhD at Manchester to join a startup that was working on mobile phone telephony networks. And I fell into a project that was using sort of AI for fraud detection on mobile phone networks. So checking if phones were cloned. And that's where I sort of first got my feet wet, I guess, with respect to systems that were, trying to be adaptive and understand what was going on in a network and therefore, respond to that appropriately and identify events and anomalies in that network for a business need.
See, so you started in signal processing in England, moved here working on the semiconductor industry, which was a different industry. So how did you jump into the software industry? What was the dynamic that made you jumping across industry? And how did you end up being, a data scientist in the software industry?
You try and be data driven with respect to what you're doing. You're using data all the time to inform decisions that you're making. Fundamentally, it's these common tools that are used in many industries. And data is now a very important, it's always been an important part of business, but it's being more and more recognized as something that can be mined for value. A lot of businesses generate a lot of data, and that data is often being just sitting around unprocessed.
In this process of moving from the semiconductor industry more into the software, that it seems it was basically driven by the fact that you were analyzing data first in the semiconductor industry, and then there was a natural evolution and going into other industry, analyzing data. What type of skills did you have to develop in this transition? Were there anything that changed going from one industry to the other one?
Most of the time, the sort of from an abstract level, the core skills are much the same. So in terms of data analytics, a strong sort of mathematical and statistical understanding and comprehension. Typically, it would be within each business, they often have their own flavor and I guess lingua franca that they use. And so that typically tends to be the piece that you need to develop when you switch between businesses, is understanding how they talk about data, the kind of business problems that they are trying to address, and then, the toolkits that they have available and that they, have standardized on.
What other adaptation you need to take into account when you move from, one industry to another?
I always worked in an R&D department, so always doing research and development. So there was always, I was always fortunate, I think, that the managers I had always had this sort of curiosity about the business. It's very collegiate, I guess, in many respects. I guess I was kind of lucky in my career in that I've been given quite a bit of free rein. So I found most of the management teams that I interacted with fairly, open and easy to work with. I guess the key problem is sitting down and taking the time to understand the domain they're in and the problem that they're trying to address. So that's where you have to spend most of your time initially, is really immersing yourself in what the business is doing.
If I understand it correctly, you say adaptation to different type of management styles and environments is less than an issue for somebody who's been in R&D, because those departments tend to give some level of freedom, some level of if you like, academic operation to a certain extent. But on the other end, understanding really the business is the challenge. It's the one thing that you would recommend anybody else that is trying to jump from one industry to another one, from one company to another one, and the typical Silicon Valley behavior of jumping from one thing to another and keeping kind of your brain always alive. You're suggesting just focus on understanding the business and what are the metrics and the language. So, and that's I think what our audience should retain: understand the language to understand the business, so that you can be effective as a data scientist. So you really have worked in a lot of projects. So I went through your LinkedIn, we talked before this interview and so on. But is there a project that was, I don't know, difficult, it was challenging, it was interesting, that you were to tell us about?
I've worked on a few interesting projects, and throughout my career, the various ones that I've had, have different kinds of challenges. I mean, sometimes you have issues around which are more around personnel, and sometimes technical challenges. A recent project that I worked on for a large retailer was very interesting in the sense that I was consulting for a business that was offering a machine learning solution to this retailer, which was around improving the quality of their catalog.
So just for our user to understand, the catalog is basically the list of items that gets displayed on the website. And it's all the information about those items: pictures, title, description of the item, and to a certain extent, depending on the retail, it could be other information like reviews and so on. This depends on the type of retail, but that's what the catalog is in the digital era, basically.
And there's a huge number of parameters. Sometimes there's they have to have parameters around local laws. So in California there are certain laws around presenting information about the environmental impact of the product, or potential issues around it may have cancer causing elements in it or whatever. So, and in other locales that's not an issue. So all of this information is sort of bundled into this sort of catalog document, and then filtered and presented to the end user on the website, depending on the locale and the local requirements for certain information to be presented. One of the issues that they have is that they deal with a large number of suppliers, so they were scaling up their catalog from around about 5 million SKUs to over 100 million, moving towards a couple of 100 million SKUs. And the suppliers that provide that data, some of them, English is not their first language, and they may miss fill in information on the sort of in that sort of data packet that's provided. Oftentimes they may provide multiple SKUs, and the person who's doing that entry may maybe they've used some sort of automatic process, and so some data gets filled in that's not appropriate. Like, for example, we would see things like fuel type for a cell phone cover, and that field would be populated. And then on top of that, we discovered they had some issues with respect to curation. So they used to sample their catalog and find out, when someone looked at the website effectively, was the information for the product displayed correct.
If we summarize, there are two levels of challenge. First is a more atomic challenge, that the information could be wrong. That the atomic information, the title, the description could be wrong. And then there is a second challenge, which is either the pictures are not displayed correctly, or the title is the description is in the wrong place. Around this problem, things get much worse when we think that they have 5 million products and now they want to go to 100 million. So basically there is no human power, like you wouldn't need to hire a army of people to curate 100 million products. So there has to be a way that we go about solving these problems. Did you try to solve both of them? The atomic level problem and the more like sophisticated curation problem?
Initially, the ask was, just to identify products that were misclassified in a taxonomy. We started with that, but the neural network that we built for that, we were able to then basically push out something that would give a likelihood score for where it thought in the taxonomy that the item should sit. One of the things we were finding, you do a lot of statistical analysis. You're looking at, you've got curated data, which you kind of rely on initially to be accurate. But then what we were finding when we were pushing back the curated data through the network, it was saying, some of these items are miscurated. So that ended up being something that was valuable, obviously, to this business. So what we were seeing was something that we called sort of cognitive priming, whereby someone would be, a human curator would be given an example like, this is what sits in this category, and if that had been categorized, they would then be likely to then miscategorize a bunch of other items. So we were able to start addressing some of those problems for them, and it was this was very costly for them, because even though they were using a kind of mechanical Turk, using these sort of crowdflower solutions where, you have human curators looking at the catalog, this was causing, they weren't able to get through the catalog at the appropriate speed. And then, of course, getting this human error.
How do you convince yourself that you're actually improving the situation and not worsening it once you operate with machine learning?
All of our results were then checked and validated, so that we would give them, we would say, these are the issues we found, this is where we think the product should sit. And then they would then, so for example, we might return them, 500,000 errors that we found in the catalog. And then they would sample those, and then using a statistical approach, identify whether a human curator was agreeing with the machine learned curation. When they brought back the errors, we would then sample those errors ourselves to see whether the human curators had actually made an error as well. So, there's lots of sort of double checking, and then there was required some retraining for their teams.
So this shows, in my opinion, to the audience and whoever is interested to really see the real projects happening in large internet companies like the one that you're talking, how complex is the reality compared to the theory. When you go and study machine learning at school, we talk about precision, the algorithms, and so on. But the reality is that when you go implement it at this level of scale, you will confront with the problem of verifying if what you're doing is correct. And again, you have to go back to human beings. When you go back to human beings, you have two levels of complexity. One is you had to choose how they're going to operate because they have limited bandwidth. If they had to check whatever you have done, then there is no meaning in whatever you have done. So you have to come up with a strategy that for what they had to do that is meaningful and representative of the broader millions and millions of products you're working. The second thing you need to care is that they don't make a mistake in measuring this thing. And so the mistake basically gets retro feedback into these algorithms. So, Mike, just to conclude on this, would you agree that in this particular situation, the overall quality of process overrides the sophistication of the individual algorithm, or does it exist a technology that could solve them completely?
I think we always want to have human verification. So, I mean, I know there's been a lot of advances with respect to things with image analysis, for example, breast cancer. But, you know, at the end of the day, people always want to trust a person. And I think that, you know, there's always going to be that bias to some extent until we feel fully confident. You know, I mean, same with self-driving cars. You know, we currently, you know, with self-driving cars, there's two drivers in the car. You know, there's two people in the car to make sure that, you know, whatever happens, you know, there's someone human to sort of take over. They're believed to be able to make a better decision for the next few years or so. The desire to have humans sort of still being able to override whatever is being sort of decided by the machine.
So, and this obviously is happening in sectors that are critical, where the outcome of the algorithm is critical, because it could determine the life or death of one or multiple people. But it is also happening in sectors where there is no a life or death situation, but from a business perspective, there could be a significant financial loss if, let's say, misplace a television from one place to another one and people would never find it. Maybe that's the top selling television. So you're going to lose millions and millions of dollars on these large internet platforms where you have millions of people going every day. So with that said, you now work in the field of machine learning applied to medicine. You know, like what are the macro trends on the technology side that you're seeing in the medicine field? Like, for example, what type of machine learning is being used? What type of problems do you think are more amenable to be solved today with machine learning in the medicine field?
Medicine has shown itself to be, you know, very expensive. And when you're going forward, we're sort of dealing with an aging population, and the number of trained medical professionals that are going to be available to deal with this sort of large population is going to be shrinking as a fraction of the population that they're helping. And so doctors are going to need tools to help them sort of deal with the large volume of data. I mean, I was reading a paper recently about how long it takes, for example, for radiologists just to deal with a backlog of, MRI scans and X-rays that they have, and mammograms that they take, to basically provide, the analysis. And so they need help with that. And so, you know, there are some systems now that are performing very well in that area. And helping doctors get through that. But even, you know, in other areas of chronic disease, you know, things like diabetes and problems, you know, cardiovascular disease and psychiatric disease, understanding how drugs work, what will be effective for a particular individual, the kind of treatment plans, you know, to ensure a high level of compliance, so that those treatment plans are effective and work as intended. There's a lot of opportunity, I think, in that particular space. So looking at, obviously image analysis is shown to be very amenable to this approach, but I think delving into the medical record, the EMR, the electrical medical record, is going to be the next sort of problem that needs to be addressed to sort of help doctors get through the volume of work that they're going to be facing. What
is not possible today that you think or you envision is going to be possible in 2 or 3 years from now?
I think there are lots of areas where you're starting to deal with maybe a more hybrid problem where you're trying to incorporate textual analysis with image analysis and genomic information, for example, in medicine. So at the moment, the trying to incorporate genomic information with respect to drugs has just been kind of started. So cancer is a particular area where the sort of genomic profiling has proven very effective with respect to immunotherapies and sort of drug discovery. But it's still, somewhat, unreliable at times. But I think that's going to improve. I mean, we're beginning to see new forms of computing. Quantum computers, people are sort of starting to develop those. We're hearing more about those systems, and it'll be interesting to see, how those, change the way we approach machine learning problems. It's still a little bit more complex than that, but certainly the tools are there to make it much easier.
I wanted to thank you so much for the time dedicated. Our time's kind of, reached an end. So for our viewers, basically, we had a very interesting conversation today with Mike Mian, who is the CTO of a machine learning startup that operates in the field of healthcare. And we discussed a variety of topics. So if you're interested to learn more about these specific topics and you watch this video on YouTube, you just comment below and we'll provide you a little bit more information. If you have questions or suggestions about other topics or extending upon this particular topic, just comment on the YouTube channel and we'll be happy to cater to your needs. For the time being, Mike, thank you so much and I appreciate your time here.
Thank you, Paolo.